Hello, this is Mr. Civil once again. Please welcome to my YouTube channel. In the previous tutorial, we looked on example 5, and in today's example, we shall look at example 6. So we shall look on overturning, sliding, and if the tension will occur. So let's get started. The figure below shows gravity retaining wall retaining granular material. Using the given information, determine the following. So the information given is that the density of soil is 18 kilonewtons per meter cubed, the density of concrete is 24 kilonewtons per meter cubed, and the angle of repose is 30 degrees. The factor of safety against overturning is 2, and we have to determine if the tension will occur. So this is mainly at the joints. Then maximum and minimum pressure exerted on the base, if overturning will occur, if the sliding will occur. So let us interpret the diagram. So the length of the stem from the base is 8 meters, so we'll add 0.5 plus 7.8, that is 8 meters. The distance, the thickness of the slab, which is 0.5 meters. So this will be our toe, and this one will be our heel. So this is the base slab, and then the distance from here to here is 1.5 meters. The thickness of the stem is 1 meter, and then the distance from this point to this point is 2 meters. So first of all, we shall look if the tension will occur at the joints. So this, we are familiar with this formula. P is equals to omega h squared all over 2 multiplied by 1 minus the sine of the angle of repose all over 1 plus the sine of the angle of repose. So this omega is the density of soil, this is the height from the base, and then this is the angle of repose. So the density of soil we are given as 18 kilonewtons multiplied by the height from the base, which is 8 squared all over 2 multiplied by 1 minus sine 30, which is 0.5 all over 1 plus sine 30, which is 1.5. When you calculate this, you'll get your active pressure. This is PA as 192 kilonewtons per meter cubed. The next thing we shall find the weight of each component of the retaining wall as well as the soil. So I've labeled it over here. This is weight 1 from here to here, and then weight 2 from here to here, this rectangular section of the base slab, and then the weight of the soil. So the weight of the soil is 1, which is the thickness, times 7.5. This is the height of the stem multiplied by 24. This is the density of concrete. You'll get it as 180 kilonewtons per meter. And then the second weight, which is 4.5. So this is our length multiplied by the thickness, which is 0.5 times 24. This is the density of concrete. You'll get it as 54 kilonewtons per meter. And then the weight of soil is 2 times 7.5. This is the height, then this is the length multiplied by 18. So this is the density. You'll get your answer as 207 kilonewtons per meter. The next thing we shall do, we shall calculate V. So what is V? V is the sum of the total weight. So V is equals to W1 plus W2 plus W3, which is equals to 180 plus 54 plus 270. When you sum up this, you'll get your answer as 504 kilonewtons per meter. And then now we shall find the value of X. So Vx, this is the moment, which is equals to PA multiplied by 2.67. So this is the height from where the active pressure will act multiplied by W1, sorry, this is plus W1 multiplied by 2. So this I'll show you where I got this 2 from, and plus W2 multiplied by 2.25 plus W3 multiplied by 3.5. So I'll show you where I got these values. So let's go back to our diagram. So weight 1, we multiplied weight 1 by 2. So I'll get the centroid of this section, rectangular section. So the centroid, you divide the thickness by 2. So I'll divide this by 2. When I divide this by 2, that is 1 meter, I'll get 0.5. So 0.5, let's say it's over here. So this is our 0.5, and then you have to add the distance up to the toe. So we have our 0.5 over here, let's say it's over here, and then we have here to here is 0.5, so we shall add 1.5 to get our 2. And then the second one is this one, the weight 2, we shall multiply. So what is the centroid of this? I'll take 2 plus 1.0 plus 1.5 and then divide by 2 to get the center point of this. Let's say it's over here. So what is 4.5 divided by 2? So that is 2.25. And then the centroid of soil. So this is 2 meters. When I divide by 2, it will, let's say it's over here, which is 1 meter. The distance from here to here is 1 meter. So I'll add 1 meter to this one up to get the distance up to here. That is 2. And then I'll add the distance up to here. That is 1.5 to get 3.5. So that is how I got my 2.75 and 3.5. And then when you want to get the height where the active pressure is acting, you will divide the height all over 3. So the total height that we have is 8 all over 3. So when you divide 8 all over 3, you'll get your answer as 2.67. And then as we have all the data, we shall find the value of x. So 544, which is our v, is equals to 192 times 2.67 plus 180 times 2 plus 54 times 2.25 plus 270 times 3.5. So when you calculate this, you'll get your x will be equal to 193 1939.14 all over 544. When you divide this by 544, you'll get your value of x as 3.84. So the next thing, we shall look on the middle third rule. So the middle third rule, you have to calculate this to ensure where the x falls. So the formula is b all over 3. So this is our base. So our base we had as 4.5 meters, and then when we divide by 3, we shall get it as 1.5 meters. So we shall see whether our x will fall in the middle third. So this is 0, and then from 0 the next is 1.5, and then when you add another 1.5, you'll get 3.0, and then when you add another 1.5, you'll get 4.5. So our x is 3.84. So this means that it falls somewhere here. After 3.0, it will fall somewhere here. So our x will fall here, And then the middle third rule says that your x should fall within the middle third. So this is the middle third from 1.5 to 3.5. This is for this question, but you'll have to calculate for other lengths. So here I'll conclude that 3.85 does not lie between the middle third, hence the tension will not, 3.84 does not lie between the middle third rule, hence the tension will occur. So the tension will occur at joints. And then there is another method. So we shall find the eccentricity. If you want to find the eccentricity, we shall take our x, which is 3.84, minus half of the base. So our base was 4.5. When you divide by 2, you'll get as 2.25, and then our eccentricity, you'll get it as 1.59. For tensions not to occur, the eccentricity is equals to base all over 6. So what was our base? Our base was 4.5 all over 6. This one, your answer will get as 0.75. Since our eccentricity, which was 1.59, is greater than 0.75, hence the tension will occur on the joints. If we had our answer less than 0.75, it means that the tension will not occur. But for this case, it will occur because 1.59, which is the eccentricity, is greater than 0.75. So our tension will occur at the joints. Now we shall calculate the maximum pressure exerted on the base. So our Pmax will be the total weight all over B into 1 plus 6 times of eccentricity divided by the base. So our total weight will be the weight of the masonry wall only. So we calculated the weight of the masonry wall. The first section, we got it as 180, and the second section, which was the base, we got it as 54. So when you add, you'll get it as 234 kilonewtons per meter. Now we shall calculate Pmax. So Pmax is equals to 234 all over this is the total weight of the masonry wall all over the base, which is 4.5, into 1 plus 6 times the eccentricity, which is 1.59 all over 4.5. So when you calculate this, you'll get it as 52 into 3.12, and then when you open the brackets, you'll get your answer. Pmax is equals to 162.24 kilonewtons per meter. Since the value we got here is positive, it will be a compressive force. And then the minimum pressure, the formula is the same as Pmax, but the sign only changes to negative. So we had our total weight of the masonry wall, which is 234 all over 4.5 into 1 minus 6 times the eccentricity, which is 1.59 all over 4.5. So when you calculate this all, you'll get your answer. P minimum, this is pressure minimum, is equals to negative 59.24. So this means that since our value here is negative, the force will be a tensile force. Now we shall determine if the overturning will occur. So the factor, we are given the factor of overturning against the factor of safety against overturning should be greater than 2.0. So our M resistance all over the moment overturning should be greater than 0. This is restoring moments. M is restoring all over overturning moment. So our overturning moment is equals to PA multiplied by H all over 3. So our PA we are having as 192 times H. This is the height from the base, which is 8 all over 3. Our turning moment will be 521 kilonewtons per meter. Now restoring moments is equals to weight 1 multiplied by the distance up to the toe, and then weight 2 multiplied by the distance up to the toe plus weight 3 multiplied by the distance up to the toe. So this distance up to the toe is of the centroid. Also this one is of the centroid. And this one too of distance up to the toe of the centroid. So I showed you on how to get the centroid. So I'll just calculate here 180 times 2 plus 54 multiplied by 2.25 plus 270 multiplied by 3.5. So when you calculate your moment restoring, you'll get it as 1426.2 kilonewton meter. And then I gave you the formula that the factor of safety against overturning is equals to restoring moments all over the overturning moment. So this is our restoring moment, and then this one is our overturning moment. So when you divide this one by this one, you'll get your answer as 2.75. So this one should be greater than 0.2. So this value is greater than 0.2. Hence we come to a conclusion that the overturning will not occur, since the factor of safety against overturning, which is, we got it as 2.75, is greater than 2. Now we shall look if the sliding will occur. So this is the fourth part of the question, to determine if the sliding will occur. So the factor of safety against sliding, so this is the formula. This is the coefficient of friction multiplied by V all over PA, and this should be greater than 1.5. So in this case we are not given the coefficient of friction, but in some questions you might be given. So I'll show you on how to find the coefficient of friction. If you want to find the coefficient of friction is equals to tan theta. So we are given our theta, which is the angle of repose, is 30 degrees. So our coefficient of friction will be 0.58, and the coefficient of friction should not be greater than 1. So we shall calculate the factor of safety against sliding. This is the coefficient of friction, 0.58 multiplied by our V, which was 504, all over the active pressure, which is 192, and this should be greater than or equal to 1.5. Since we calculated this and we got our value as 1.52, which is greater than 1.5, the sliding will not occur. Hence the factor of safety against sliding, which is 1.52, is greater than 1.5. Hence the sliding will not occur. So this was the today's tutorial, and this was the last examples. You will get questions attached in the description box below. So if you have not yet subscribed, please subscribe and give us a like if the video was interesting. Thank you very much.